Hi, in this video, I'll be going through what are random variables and I'll show you what it means to describe a random variable. So, let's take this example first to better understand what are random variables. Let's say you perform an experiment and you want to be interested in the sum of the two dice. So, we may be interested that the sum is 7, but we are not concerned whether the actual outcome is the following ordered pairs. And it's the same as when you flip a coin, you are interested in the total number of heads. And so the actual outcome, the actual event of like heads, tails, or tails, heads, both show that there is only one head in both situations. And that's what you really want to capture from the sample space. And so it is really about a random variable is really a function from the sample space to the real line. So it is like a summary of your experiment. So for example, you do an experiment and you want to find the probability that the sum is 7. You know that these are the outcomes, but really what you want to say is that the probability x equals to 7 equals to 1, 2, 3, 4, 5, 6. 6 out of 36. So it is 1 over 6 chance. And so the value of the random variable is determined by the outcome of the experiment. And then this means that we can assign it a probability. Because we know that the probability of this random variable occurring for the given value is really the probability of the number of events of the outcome divided by the total sample space. And so to give a random variable, we not only give what values it takes, we must specify the possible probabilities for each event of the random variable. And that's really what we mean by saying we give it a probability distribution. And so really, the gist of it is that the random variable is a summary of the experiment, and we assign it a probability distribution by specifying all the possible probabilities. And this probability distribution really just tells us what is the chance that the random variable occurs for x equals to x. And so there are two types of random variable, and first I'll go through what are known as discrete random variable. And these are the random variables that can take on countable number of values only. Meaning they take on like x1, x2 all the way to infinity. Or it could be finite. So it's a countable number of possible values. And so we can define the probability mass function as the probability of x equals to a. Meaning, what is the value when x equals to a? And one thing to note is that all these probabilities must of course be larger than 0. And outside of this, so let's say I equals to 3.5, then the probability will be 0. Because it has no chance of occurring, since it is not one of the possible values. And since it is a probability from the sample space, when you add all the events up together, the total probability must equals 1 by the axioms of probability. And so let's take a look at this example. Let's say we denote the random variable as the number of heads appearing when we toss 3 fair coins. Then it's possible it has no heads, 1 head, 2 head, or 3 heads. And so what's the probability of y equals to 0 is 1 over 8. For 1 is 3 over 8, for 2 is 3 over 8, and for 3 is 1 over 8. And that's really because to have 0 heads, you must have all t's, which is half cube. And similarly can work out for the rest. And so I hope it's clear what a discrete random variable is. So now a common type of distribution has with a given name is called as the Belloni distribution, and that's for an experiment that only has two possible outcomes. And we usually denote it as x follows a Belloni with probability P of success. And so we denote the success as 1 and denote the failure as 0. And so the probability of x equals to 1 is P, and the probability of x equals to 0 is 1 minus P. And so you can just denote the probability mass function as this. And so to specify a distribution, it is equivalent to giving the PMF of a random variable. So if I know the probability mass function, I know all the probability distribution for every value of the random variable. Lastly, let's take note of what is a CDF. And a CDF is really the sum of previous PMFs. So it's the probability of x being less than or equals to x. Meaning, let's say the probability of x equals to the random variable is defined for 0, 1, 2, 3. Then the probability of x less than or equals to 2 is the probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2. Because you want to know the event that x could be equals to 0, x could be equals to 1, and x equals to be 2. Because it's now the probability of x less than or equals to 2. And so, it is really just specifying the probabilities that a random variable is less than or equals to x. And this is another form of specifying a distribution. So if you can specify the PMF, you can specify the CDF, and meaning you can specify the distribution. So they are all equivalent. Because if you want to get the PMF, it is just the probability of x less than or equals to x minus away the probability of x less than or equals to x minus 1. And with that, we want to say that the event that x is less than or equals to A is contained within the event that x is less than or equals to B when A is less than or equals to B. And so the cumulative distribution function is a non-decreasing one. And if you picture it, and the PMF is the following, so it's at first is 0.1, then 0.3, then 0.4, 0.25, and 0.5 again. Then, so the first one is from 0, you have already the probability of this occurring, to 1, it's the same because no other values values of x is taken here. And then for the next one, 0.3, you add on to the 0.1 over here, so now it's 0.4 like that. So just keep adding, and then you just keep increasing. So you can see it's a non-decreasing function over here. And the last thing we want to talk about in this video is a very important concept known as the expectation. And let me just give you a very good intuition about it. So an expectation, of course, we first define the formula as the sum of all the x times the probability of x equals to x. And what we really want to capture with this formula is that it is a weighted average for x. And so expectation is like a weighted average. So what's a weighted average, you may ask? Let's say you have a few numbers, 1, 2, 3. Then the average of these numbers is 1 plus 2 plus 3 divided by 3, which is 2. But let's say now that 1 has a very, very high chance of occurring. Let's say 0.9 probability. Then 2 has a 0.1 and 3 doesn't even occur. Then of course, now it shifts to, we are more likely to have a value occurring near 1 for a long period of time. And so when you average it out, it should have a value closer to 1 as compared to 3, because 3 doesn't even occur already. And so the weighted average means you take into account the probability for each of the value occurring, and then you sum all of them up. And so really, when we say 1 plus 2 plus 3 divided by 3, is really 1 times 1/3 plus 2 times 1/3 plus 3 times 1/3. And this 1/3 is just the equal chance of occurring. And so now you're just changing this 1/3 to the different probability mass function. So with that, there are certain properties of expectation, and the first one is the linearity property. So the expectation of ax plus by is just a times expectation of x plus b times expectation of y. The proof of this is given in the textbook by Sheldon Ross, first course in probability, so I won't go through it. And the second property is that the probability of, let's say you run your function x through through a function g, then it has some new value. So x is over here, and then you run it through a function g. So g has some new values over here. Then the expectation of gx is just gx times the probability, because the probability distribution did not change. If you think about it. So let's say gx is here now. The chance for g1 to occur, let's say the g1 is the same it must have the probability that x equals to 1 from the domain. And that's why this equation holds. Of course, you can look at the general proof in the textbook, but the intuition should follow accordingly. And hence, let's just take a very simple example to summarize our conceptual understanding of what is expectation. And so let's take EX to be the expectation for when we roll a fair dice. So the probability of any of the values occurring is 1/6, and so when we sum them up is 7/2. Of course, we like to see that we will never ever hit 7/2 when we roll a fair dice, but it's really not about that. It's really about the weighted average. So meaning you get 1 at the start, you get 6, then you add them up, it's like 7, then you divide by 2. So you get is having an average. And so when you write out the distribution, it should be like this. And really, when we talk about continuous distribution, you understand how does this average come into play in the distribution. Then the expectation of x squared, you just need to square all of them and then add them up, and you get this. And then when you want to multiply 7 in front, you just pull out the 7 and you get this. So it's really very simple, and I hope you can practice more in the textbook. That's all for this video, and I hope you understand what are random variables and its expectations. Thank you for listening, and feel free to like, share, and subscribe, and leave your comments down below. See you.